Very good morning to everyone. Today we are going to discuss about the robotic subject. In the robotic subject, we are discussing in this video Unit 1 Fundamentals of Robotics. So first we want to know about robots. What is by robots? A robot is a reprogrammable multifunctional manipulator designed to move materials, parts, tools or any devices through various programmed motion for the performance of a variety of tasks. So using the robot we can perform many tasks. So what are the works are not able to done by the human being, hazard places, those work can be done by using the robots. So a comparison between the robot and the human being. So human being having brain to perform and control all the tasks. In robot having processor. For automation we are utilizing computer chips and softwares for the function of as like the brain. Skin and ears, nose for the human being for sensing purpose, for temperature sensing, and then hearing the noises and smell some smokes, like that. Same function will be done by the sensors in the robots. So lights and sounds and temperatures, like that. For view the objects we can using the eyes we can view the objects, but in the robots we have vision systems. So using the machine vision system it can able to view and identify the objects. Then arms and hands used for human being is to handle the materials, to pick the workpiece. So using the fingers we can take a workpiece or tools and something whatever needed. So as like that in the robots, end effectors are utilized to pick the project objects or do some works. Okay, as like the feet is used to, we have to move from one place to another place. Similar as in the robot system, it having a transportation system. So using the transportation system, it can able to move from one place to another place. Next, we are going to discuss about the robot anatomy. So, robot anatomy is nothing but the physical construction of the robot. That means how the body of the robot is constructed, and arms and wrist and fingers and effectors are positioned. So, what are the parts it having? The parts are how it's are assembled, then how they are function. These things we have discussed in the robot anatomy. The figure shows the robot anatomy of the basic robots. So it is a pick and place robot, whatever maybe. It having a base to mount over the floor. Then over that it having a shoulder and elbows and some joints are there. Depends upon the type of robot and purpose of the robot. It having some joints as like linear joints or rotational joint or transverse joints, whatever maybe. Depends upon the function. End of the robot arm, it having the end effector for the purpose of doing our task. Maybe we have using fingers mean it will be used for pick and place. That means hold the object and take to some places and left the object. Likewise, otherwise instead of the fingers we have utilize the machine tools. Using the tools we can perform some other task. So these are the anatomy of the robot. So types of joints. So we have to know what are the types of joints available in the robot. So joints are linear joint, orthogonal joint, rotational joint, twisting joint and revolving joint. So linear joint means the motion between two links, input and output links will be linear. That means straight line, as like shown in the figure. Okay, input link is it is available in the left side. The right side it is having the output link. It will the relative motion between the input and output link will be the straight manner, mean it is called as what's that linear joint. Then orthogonal joint means the output link will be perpendicular to the input link, but the motion between the input and output link will be straight line. but the output link is perpendicular to the input link. That's why it is called as what's it, orthogonal joint. Next we are going to discuss about the rotational joint. The output link will be the movement of the output link will be rotation about the input link. That means about the end of the link it can able to moving right to left. Likewise it can able to move, means it is called as what's that, rotational joint. Then next one is the twisting joint. Twisting joint means input link will be fixed, the output link will be rotating about the same axis of the input link. So both the link having the same axis, but the output link only rotating about the input link axis. So it is called as twisting joint. Then revolving joint means the output link will be perpendicular to the input link, but it will rotate about the input link axis. So it's called as revolving joint. So these are the configuration of the different robots. So for cylindrical configuration, Cartesian coordinate configuration, polar configuration, joint arm configuration, then selective compliance assembly robot arms, they simply called as SCARA, then serial manipulator configuration, then parallel manipulator configuration. These are the configuration of the robots. It is depends upon the work envelope, that means work volume, how the robot can able to reach, depends upon the configuration we have classified. For example, cylindrical configuration means it can able to reach cylindrical volume. That's why we called as its cylindrical configuration. It having a rotational movement and one vertical movement and also a horizontal movement in the x direction. So it will reach as like the cylindrical configuration. So it is cylindrical volume. So it is called as cylindrical configuration. The figure shows the hidden line figure shows that how the arm of the robot reaches. It is as like the cylinder. So the work volume, otherwise it is called workspace, otherwise it is called work envelope. If it reaches the cylindrical shape, means it is called as cylindrical configuration robot. It is used for the purpose of material handling, loading, unloading, and palletizing. And then Cartesian coordinate configuration means, otherwise it is called a rectilinear robot. That means all the movement in the x and y, z, all the direction it will move linear. So that's why it is called Cartesian coordinate configuration. So x-axis movement also linear, y-axis movement also linear, z-axis movement also linear. So that's why it will reach us about as like a cubical form. So it is called as Cartesian coordinate robot. The figure shows how the robot arm moving, it can able to reach. So the work volume is as like the cubical form. That's why it is called as Cartesian coordinate system. For it is also used for the purpose of assembly function, inspection, and loading, unloading function. We are utilizing this robot. Next, polar configuration. Otherwise, it is called a spherical configuration system. So it having rotational and twisting. So the vertical about the vertical axis can able to rotate 360 degree. Then also about the horizontal axis can able to revolve, and also it having extension and retardation motion at the end of the arm. So it can able to reach as like a spherical shape. That's why it is called as a spherical coordinate configuration, otherwise polar configuration. So this figure shows the how the work volume of the polar configuration robot reaches. It is also used for the purpose of machine assembly, injection molding, machine tool loading and unloading, handling of heavy tools. For the purpose we are utilizing this one. Then next one is the joint arm or articulate configuration. So articulate configuration means it having all the joints are revolving joints. So about the base also it can able to revolve, about the between the links also it having rotational joints. That's why it's also moving as like the spherical shape only. So it is called as articulate configuration, otherwise joint arm configuration, because of all the arms are joined, that means pin joints only, it having no linear extension or retardation joints. So it is called as joint arm configuration. So it is also utilized for the purpose of arc welding and spot welding, Then automobile assembly purpose we are utilizing this one. Then next one is the SCARA robot. It is specially designed for purpose of the assembly. So it having linear one linear joint at the end. The remaining joints are revolving joints. That's why it is called as SCARA robot. It is for the purpose of assembly purpose. It also moving in the work envelope of cylindrical shape only. So it is utilized for the packaging, palletizing, and assembly operation. So next one is the serial manipulator for configuration. Serial manipulator configuration means all the joints are linked with each other. There is no relative linear movement between them. They have only rotational movement with the pin joints. So it is called as a serial manipulator configuration. This is also parallel manipulator configuration. One end effector is connected with multiple links of joints. So this configuration is called as parallel manipulator because of each links are parallel to each other. That's why this diagram shows the chart shows the configuration system with payload and number of axes and repeatable and work volume. So next we are going to discuss about the robot parts and function. So it having body or structure, then power or drive system, and controller, then manipulators, sensors, end effectors, and processor. These are the parts of the robot. So we know very well about the function of the robot. So body, it supports components all the components of the robot. This will give the physical appearance to the robot. Next one is the power supply and the drive system. Power supply is main source to operate the robot, and also drive system is how we can make the movements by using the hydraulic system or a pneumatic system or electrical system. What are the systems we have utilized to, what are the powers we have utilized to make the motion in the robot. That is called as what is the power supply. Then controller or actuator, it making the motion. For example, cylinder, piston cylinder arrangement or motors. What are the things we have utilized to make the motion? We give the power supply to the motor, it will create the rotational motion or linear motion or reciprocating motion, whatever may be. So how the information we get it, if we are give the signal to the piston cylinder arrangement, if the piston is extended, so the arm extended means if I want to reach 50 mm, if it is reached 50 mm or not, from the sensor we can get the signal. So if it is not reached the 50 mm distance means then automatically the control system will give the signal to the processor. Then we can further we have to move the arms to 50 mm distance. So likewise the controller will act. Then the manipulator is how the materials transport from one place to another place, what are the direction we have to move, that is done by the manipulator. Then sensor is the main device to function the automatic, and we have give some task to the robot, if it done or not, how can we get it? So by using the sensors we can able to find it will reach the task or not, depends upon that the control unit will be function. So this is the main purpose of the sensor. It having many types. Sensor having many types for the purpose of temperature, pressure, and load, and many purpose we have utilizing this. Then we can discuss about the end effectors. End effector is utilized it only do the task. So if I want to pick a object means the end effector will be hold the object, then we want to place the object means it will leave the object where we want to place it. So the function will be done by the end effector. Instead of the fingers we can utilize the tools, some tools, drilling head or welding head or painting head, whatever maybe we can mount it at the end of the arm, that will perform our task. So the end effector will be done our task. This is the main purpose of the end effector. So working of the robot, if we gives what are the programs to the CPU. depends upon that it will act, that execute the signals to the end effector or whatever end effectors or a drive system and a manipulator. So it depends upon that the robot will be functions. So input of the robot will be sensors and transducers. That means from the sensors we can get the signals. Depends upon that the control unit will be act by the by the CPU CPU programs. The output performance action to the end effector. So what are the tasks we have to do? The task will be done by the end effector only. So these are the parts and function of a robots. So role of the robot in industries. So many industries in fully automatic industry, automation industries fully utilize the robots for the purpose of machine loading and unloading, pick and place, then palletizing, arc welding, spot welding, spray painting, then assembly unit for car manufacturing and inspection sections and packaging. For the purpose we can utilize the robots.